A very good afternoon, everyone. So, in the morning, when the session started, followed by the puja, that time also we discussed in brief that what we are going to do in this course, and by now you have attended the classes, I think, of geology and chemistry as well as botany, right? So now we will be dealing with physics, and since being the first class of physics, so I'll be briefing about few points about what is physics and what all we are going to see as the course will commence in the upcoming lectures, not only online. When you all come here and join us in offline mode, there also, while you are reading each and every chapter of physics, so what all things you are going to expect, what all things are going to come, and how it is going to be different from what you have studied up to class 10th, right? So it is means you can think of it like nowadays, you know that whenever a movie comes, so before the movie they show, the filmmakers, they release a trailer. So what is the purpose of that trailer? The purpose of the trailer is to give you a glimpse of what exactly is going to happen or what you can expect from the movie when it will be finally released. When the movie comes, then you will have an idea, okay, these all things we have seen in the trailer, and now we are waiting for those moments to come in the actual movie, which will be of a longer duration, obviously. So similarly, we will see, or we will have a brief overview of what all chapters we are going to study over here. But before doing that, we come to the main point, which is, since we are studying physics, so everywhere when physics is first taught, so first lecture itself we discuss what is physics. Now we'll try to make it interactive as possible. So later on also, when you will watch the video again, you can make note of the points. No need of writing those things in a hurry. At least listen and see what all points we are discussing. In the meanwhile, while we will be seeing various points, I'll be asking a few questions, just that I may receive some answer from you, and we can then discuss that whether the answer given by you is correct or it needs some say improvement or some correction is needed, those all things. So coming to this point, what is physics, what exactly we do in physics, and why do we study physics for NEET? Now this question also many a times it brings nightmare in the minds of several students, that we are going to become doctors, so we have to study say biology, that is botany and zoology, and to some extent chemistry. But what is the need of physics then? And we have heard from our seniors or our elder brothers and sisters that physics is very tough. Even for JEE aspirants who are becoming engineers, for them also they have to study physics along with mathematics and chemistry. For them also physics is tough, but okay, they have to study because for being an engineer they need to learn physics in detail. But why for medical aspirants? So the answer lies in that you would have heard that when we go to doctors, so there are different types of doctors, right? Every doctor will not treat you by giving a paracetamol. Some may treat you for different sickness or different disease in different ways. You may have a doctor who will just be prescribing medicines based on the ailments that he can observe directly. Some may go for surgery, or many a times you see that when you go to a doctor, they will ask you that get this tests done, like tests like MRI or CT scan, ECG. You have heard of these all. So can anyone tell? You would be knowing, I think, that which type of doctor will specialize in these all tests, who will give the results to you for these tests, MRI, CT scan, or say X-ray, and all such cases, ECG and all, who will give you the test results? So I think we can check for is there any option that we can check for your comments. So let me check with my technical team over here, so how we can see your comments. Yeah, very good. We are seeing several correct answers. Yes, it is a radiologist, right? So fine, great, radiologist. Okay, some students are, I think, complaining about the volume being too low. So can we get a quick response on whether everyone can hear me properly, or it may be a local problem for some of the students? Okay, fine. So we have got this thing that yes, you can hear me, fine. So a radiologist, he deals with what we call as MRI, CT scan, X-ray and all. Now for these things, knowing the concepts of physics is very important. So we have dedicated chapters in physics which gives you a brief introduction about X-rays, different types of waves. We have chapters called magnetism. In magnetism, in current, electricity, electrostatic, you will know about the underlying principles on which these machines work, MRI, CT scan and all. Similarly, you all know about something what we call as a BP monitor. BP monitor, it is used to check our BP, pulse rate and all. So that also, for knowing that, the doctor who is checking your pulse, he should have the knowledge, he or she should have the knowledge of pressure, how pressure of fluids gets transported or transmitted from one point to other in our body. So he should have the knowledge of pressure as well. So physics everywhere is important. If you talk about ultrasound, there is a technique or concept used in physics which is called as Doppler's effect. By using Doppler's effect, a doctor can detect whatever is going on inside our stomach or abdomen. So yes, have some patience. I will be definitely writing what all things we need to know presently. Don't be in a hurry, even I am not. Okay, we don't have buses to catch, I think. So in physics, we have a lot of scope, lot of concepts on which you can say the study of medicine is based on. So presently coming to the most important definition, which everywhere in a bookish form they study, it is physics is the study of nature. Well, physics is not just a study of nature, it actually deals with all the laws and explanation of the laws on which every phenomena, everything that you see around yourself going on or taking place, they are based on which phenomena that is explained by physics. So we say this physics actually deals with the laws and explanation of these laws which govern any natural phenomena. So whatever occurs around us, it will be explained by what we call as physics. But to understand everything, you have to dive very deep, which is not possible in a particular stage. So up to 12th, you have certain laws, only you can know about that. If you take physics and if you study higher and higher, then in that case you will come to know that yes, there are way more things that you haven't learnt yet. So presently what we say in the most basic form, it deals with the laws and explanation, but for what is going to help you for your NEET exam, in that way if I have to define physics, what it says is, It is simply the study of what we call as physical quantities. It is called as the study of physical quantities, their interdependence. So, how these physical quantities depend on each other, in what way they are going to affect any object. So, these all things, this study we say is the study of physics. So, it is simply the study of physical quantities and their interdependence. Now, the question is, what do we mean by physical quantities? What do we mean by physical quantities? Can anyone reply, what do we mean by physical quantity? So, what is a physical quantity? Fine. So, we have got few answers over here. Mass, someone is saying measurable. Okay, right. Physical quantity is anything that is measurable. Whatever you can measure is called as a physical quantity, correct? We will be discussing in detail in a particular class when we will be dealing with physical quantities like fundamental and derived and all. Presently, as I told today, we will be just briefing about few things. Okay. So, physical quantity is anything that is measurable. Now, there are lot of physical quantities, but what we do is we can classify the physical quantities into two important types. Two important types in which we have classification of physical quantities. Can we have an answer for this also? Yes, it is correct that it is measurable. So, quantities that can be measured. Can we have an answer for this? That what are the types of physical quantities you have heard of? How can we classify physical quantities into two types mainly? Yeah, correct. Scalar and vector. There is also a generalized set or collection of such quantities which we give a name called tensor, but we won't be wasting our time in that. We have nothing to do as far as the syllabus of NEET is concerned. So, we just classify physical quantities mainly into scalar and vector, right? See, some are answering fundamental and derived. There are different types of classification. One type of classification is based on a quantity being fundamental and derived. That is a different thing. But when we talk about another classification, scalar and vector, here we talk about something called its magnitude. Here we call about something called its direction. So, in that way we have scalar and vector. Now, what is the difference between a scalar and vector? So, first, if we talk about vector, it has what we know as magnitude or value. Now, that so this also has, scalar also has magnitude. Now, what is the difference between scalar and a vector quantity is what we call as a fixed direction in space. Sometimes students say that sir, vector means direction. Not only direction, you have to know this word, extra word that we are using over here, which is what we call as fixed. The direction should be fixed. If the direction is different along different directions, if a physical quantity is present, so it won't be what we call as a vector. So a particular vector should have a fixed direction. Okay. What about scalar? Can scalars have direction or not? Can anyone reply? Okay, they are saying vector has direction but scalar doesn't. But if you think a bit more, you will come to know that there are some physical quantities, like all of you know it. One is called electric current, one is called time. Now they to have direction. Electric current, you know, flows in a wire along a particular direction. If you apply a battery in a circuit, electrical circuit, then what will happen? You have heard the word voltage or potential difference. So current will flow from higher potential to lower potential. So it has a direction. Time, we say that time is going on in a particular direction. Since we can say that it is going in a particular direction, we call it as forward direction. We can go into future. We are presently going into the future, not towards the past. So they also have, sometimes they also have direction. But what is the difference now between scalar and vector then? Here, yes, here in case of scalars, what we can say, scalars may have direction which is of no significance while measuring it. So when you measure a scalar, there is no significance of its direction, that it has to be in this direction or that direction. So such type of quantities for which direction is of no significance, those we call as scalar. And which quantities have a fixed direction in space, they are called as vectors. So here we have the role of direction also. That means in this particular we can say case vector, they have a fixed direction and they obey certain laws of addition, subtraction and multiplication, which scalars don't obey. So when we will be dealing with these chapters, there you will be coming to know about certain laws of mathematics or certain mathematical operations, addition, subtraction and multiplication, which scalars won't obey. I'll just take names over here. You will come to know of triangle law of addition. There is a parallelogram law of addition or a generalized law for vectors which is called as polygon law. It is called as polygon law. So these laws are obeyed only in case of vectors. These laws won't be obeyed by scalar quantities. Electric current, even though it has a direction, again I am saying electric current may have a direction, but electric current won't obey the law of addition, subtraction or multiplication, which are specific for vectors. Understood? So scalars won't obey those laws. So this is how we can differentiate between a scalar quantity and a vector quantity. So lot of examples are there. We will just take one or two names here quickly, like you have heard of distance, speed, energy, work. These all are scalar. Current also, electric current, as I said, that is also a scalar. Similarly, you have quantities like velocity, you have a quantity like linear momentum, you have force, you have acceleration, you have torque, angular momentum. Lot of such quantities you are going to see in the upcoming classes. So these come under the category of vectors. Now one thing more, can anyone point out anything missing over here in this? I have used some mathematical operations which vectors follow, and I have written that they have certain laws of these. Is any mathematical operation missing over here? Can anyone point out any mathematical operation missing out over here for vectors? Please, I am waiting for your reply. Yes. Okay. Fine. Correct. We are missing division over here. So from now onwards, make it a point. Remember, what is to be remembered? Division of two vectors is not defined. So you cannot define the division of two vectors. So you can divide their magnitude, mind it, listen to me carefully. You can divide their magnitudes. Okay. Suppose there is one velocity, there is another velocity, you can divide their magnitudes. When we say force is equals to mass into acceleration, force is equals to mass into acceleration, which all are the vector quantities here and which one is the scalar? We say that force is vector, you say mass is force is vector, mass is scalar, acceleration also is a vector. Now vectors, they are represented by certain symbols. When we have force, you all have heard Newton's second law, force is equals to mass into acceleration. Force is equals to mass into acceleration. Out of these three, I said that which one is vector? This is vector, this is scalar, mass is scalar and acceleration is vector. How do we express or represent vectors? If I am writing an equation mathematically and I want to let anyone know who has studied physics that this is a vector, this is a scalar, is there any representation? Is there any representation where I can make this equation more crystal clear? If I want to represent it that this one is vector, this one is scalar, how do we do that? For that purpose, we will study in detail. Yes, correct. We use arrows. We use arrows. Whenever we put an arrow over the head of a physical quantity, it shows that it is a vector quantity. So F vector is equals to ma vector. Now F vector is ma vector, but here m mass is scalar. Now here, if I write F is equals to ma, this equation is correct. This equation is correct. But if I write m is equals to F vector by a vector, is it possible? If I write F vector by a vector is m, is it a correct way? Is it a correct way of writing? Answer is no, you cannot. You cannot divide two vectors. So it is incorrect way of writing. This is incorrect, just like you know 1 into 0 is equals to 0. This means you can write 0 by 0 is equals to 1. So this is wrong. So if this is wrong, similarly this is also wrong. So you cannot write this. Instead, what we can do, when we are putting an arrow, that arrow denotes the vector. But if I want to write this correctly, what would be the correct representation for this? If I want to represent it correctly, what would be the correct representation? Instead, I can write mass is equals to F by A without giving arrows, where these denote magnitudes of force and acceleration. So if you are using just the magnitude of force and acceleration, you can represent it correctly. So this is a correct way. So whenever you have two vectors which are related by mathematical multiplication, mind it, whenever we have two vectors which are mathematically related by multiplication, such that a vector is some scalar times other vector, a vector is scalar times some other vector, then that scalar will be the division of magnitude of this vector by magnitude of this vector. Understood? So this is a very important point that everyone should be aware of, and I want to quickly get a response from you. Did you understand this or not? Okay, fine. So you saw when we were talking of physical quantities, we have measurable quantities as physical, and these are of two types, scalar and vector. Okay, so we will proceed further. Fine. Now we will proceed further. Next we will see some important technical terms, some of which you have definitely heard, some you may not be knowing, but don't worry, in detail we will deal with each one of them in the chapters to come. Important technical terms used in physics. So there are some terms which we will be using in physics. Now, first one, is a system and surrounding. System and surrounding. Now, what do we mean by a system and what do we mean by a surrounding? So, whenever we are studying, whenever we are observing something, the whatever you observe, whatever you are observing is called as a system. Whatever on whichever object or a collection of objects on which you are applying some law, that is called as a system. So, what is a system? It is an object, or we can say a collection of objects which is being observed or on which laws of physics are to be applied. Laws of physics are to be applied. So the object, single object or collection of objects which is being observed, that will be called as what we call as a system. Can anyone now tell me what is meant by a surrounding? So if system is whatever we are looking at, whatever we want to know what is going to happen with it, that is called as a system. Now what do we mean by surrounding? Can anyone say here, what do we mean by surrounding? Okay, someone is replying environment, medium. Okay, so surrounding, in simple words, whatever is external to the system is called, yes, the best answer I think I got from here is in which the system is present, right? So surrounding is anything, it can be anything external to the system. Whatever is external to the system and with which the system can interact. So the way in which a system can interact through some process, for that you need something which should be external to the system, and that is called as a surrounding. So system which is being observed, and when you are observing a system, then you are part of its surrounding. So when I am an observer and when I am looking at something, so that something which I am looking at becomes the system, and I am looking from where? From the medium in which the system is kept. So I am part of the surrounding. Understood? So this is system and this is surrounding. Now these systems, it is so clear. Now in system we use another terminology which is called as an object, you saw, and what we use is a particle. Now what do we mean by this word particle? Here I said it is a collection of objects or a single object also. But what is the meaning of a particle? What is the meaning of a particle? Can anyone give any reply for what do you mean by the term particle? What is a particle? I am talking about particle, not the surrounding. What do we mean by particle? A single substance, then what is an object then? A single object. If I tell this pen in my hand, what is it? It is an object, a single object. So how can you say it is a particle? Okay, some reply we are getting like it contains positive and negative charges. What if the particle is not charged, or what if the object is not charged? Point sized object. Okay, somewhat correct, right? Particle is a substance with which matter is made, but matter is so made of atoms, I think, at the basic level, and below that also there are quark particles, okay, and everything is made out of energy. No, what we say for a particle, let's be clear from here itself, so that you later don't have any problem understanding it. Particle is the smallest form in which we can observe any system or object. The smallest form in which we can observe any system or object, that is called as a particle. So if you talk of that particle means that it does not have size, is it a correct statement? Is it a correct statement if I say particle does not have size? Is it a correct statement if I say that a particle does not have size? I'll quickly make this confusion over for you. I think Lakshmi, Akhil, that you are saying object is made up of particles. So I'll make that confusion over. See, I am saying the smallest form in which we can observe any system, which we can observe as an observer. So it depends on how you are looking at the object. Now you see, let me go back to the previous slide. Like here, you can see this all thing written over here. If I zoom out this page, let's focus on this particular letter M. you can see this letter M. Let's focus on this M. Now it is looking like a big object. It is looking like a big object to all of you. I hope it is clear. So I am also seeing it as a big object. But if now I zoom out, if now I try to zoom out, means make its size as small as possible. So here we have a limitation for this board, but still if we try, at least for you, you can see that its size got reduced. So object and particle, you cannot say that object is a collection of particles. A single particle can also be treated as an object. It all depends on the observer. The smallest form in which you observe something, that thing is known as a particle. So when do we consider an object as a particle? Now if I say, for example, if I say to you that sun, is it a particle or a sphere? You will say that sun is a sphere. What is earth? Earth is a sphere. It has very large size. Our earth, it has a radius of around 6,400 kilometers. Just imagine how big it is. But if we consider ourselves with the size of earth, what we can say? If we consider ourselves with the size of earth, our size is so small, so we will be treated like a particle. If someone watches us from space, not from moon or somewhere, say from an aeroplane which is say about 1000 feet in air, so for that person, might be your parents, your relatives, they are on the plane. When they were on the ground in front of you, did they look at you as a particle? Answer is no. But when they are on the plane and suppose they are looking at you, you are at the airport and they are waving at you or looking at you, how will you appear? Will you appear by the same size as what they were seeing you on ground? The answer is no. You will be looking just like a particle. So this is that word particle. When we consider an object in its smallest size or smallest form, we call it as a particle. So what is the best way in which we can define a particle is, this particle is the smallest form in which we can observe whenever the size of an object is very small compared to the separation between two such objects. We treat such objects like particles, or we also call them as point sized objects. Again repeating, whenever we have objects whose respective size are very small compared to the separation between them, then we can treat such objects as particles. Sun and earth both are spheres, very very large spheres. Sun is larger than our planet also. But if you consider the distance between the sun's center and earth's center, the distance is so large that we can treat sun and earth as a particle compared to the large distance between their centers. Stars we see in the sky, they are not small, but we see them as particles because of the distance. So that is how we define a particle. So I hope this thing is clear. What do we mean by system and what do we mean by surrounding? I hope it is clear. Now systems we can again classify into three types. One we call as a closed system, one we call as an open system, and one we call as an isolated system. There are three types of what we call as a system on which we are going to see the influence of surrounding. So the system can be said to be closed, open, isolated. Now can any one of you tell what do we mean by closed system first? Quickly reply, what do we mean by a closed system. I request all of you to be a bit serious in the class, because right now you may walk it off as a joke, some of you, or you may be thinking that some fun or something is going on, but when we will later study these chapters, these all terms, when they will come, if you have a clear perception or idea of what these are, you won't face any difficulty. So it is for your benefit, these classes are being kept for your benefit, kindly utilize it. So okay, so when we talk of closed system, let me make this clear. What is the difference between closed, open and isolated? Closed system is anything that can exchange only energy with surrounding. It cannot exchange matter, but it can exchange only energy. For example, if you have a vessel and you are heating it, so the heat energy, suppose the vessel is closed, it is having liquid inside it, from outside the heat energy will come in contact with the vessel, and from vessel it will be transferred to the liquid or the material inside the vessel. So there is no transfer of matter. Matter cannot go from inside to outside or from outside to inside. So that can exchange only energy with surrounding, not matter. When we talk of open system, what is an open system? This is something which can exchange both matter and energy, and obviously with surrounding. So when you can exchange both matter and energy with your surrounding, will be a open system. And what is an isolated system? Which can neither exchange matter nor energy. Neither matter nor energy is exchanged. So such types of systems are called as isolated systems. Yes, correct. We got several correct answers over here. So isolated, open and closed, these are the three important types of systems. And if you see that nothing can be exchanged between a system and its surrounding, we call it to be isolated. If only energy can be exchanged, it is a closed system. And if both energy and matter can be exchanged, some matter can go out also. For example, if you have open vessel, it is containing water and you are heating it from below. So it is exchanging heat, and due to that heat, some water will become steam and it will leave the vessel and go out. So there is an exchange of matter also, and there is exchange of energy also with the surrounding. Clear? So when you keep a cup of tea in the open, what will happen? Some water in it, it will initially, due to hot tea, some water will evaporate. So some water will come out of the cup and escape to the atmosphere, right? After some time you will see that the tea will become cold, because it will give heat also to the surrounding. Comparatively, the temperature of the surrounding is at lower value than the tea, hot tea. So tea will eventually give heat to the surrounding and it will cool down. And when it was very hot, suppose it was say near its boiling point, then some water would vaporize or become steam also. So there is exchange of what we call as matter. So that is an open system. Closed system, I told you in the beginning, if you have a vessel with a closed lid, it is containing a liquid inside, you are giving heat. So in that case, what will happen? there will be transfer of energy, but there won't be transfer of matter from inside to outside or outside to inside. Yes, thermos flask belongs to an isolated system, correct. If you see a normal water bottle containing water, if you keep hot water in it or chilled water in it, you will see after some time the temperature will change. If you have chilled water in a normal water bottle, after some time what you will see, the water will become warm, right? It will become warm. And if it is very hot, then also after some time it will become relatively colder. But no water will escape outside, okay. So this is what a cold closed system. But if you have a thermos flask, in thermos flask, if you will keep chilled water, after 8 or 10 hours you will see that the water will be chilled only. No water has escaped outside, nor is there any heat exchange. If you keep hot water in the flask, it will remain hot. No exchange of heat from outside to inside, and there is no exchange of matter also. The body of the flask is insulated. It is providing insulation from the external heat. So this is what we call as an isolated system. I hope it is clear. Open, closed and isolated system. Again, I am telling in a nutshell, when we have a system, the system, what can be a system? It can be a single object, it can be a collection of objects on which you are applying, say, some force, you are applying some process. This is what we call as a system, on which the laws of physics are to be applied. If you are seeing a block moving, you want to apply Newton's law, then that object becomes the system. Understood? Open system, again I am giving one more example. Open system, suppose a vessel with a open lid. Some mass can enter also inside, some mass can leave it also. Understood? So how you can say, for example, if I take a glass and I have ice cubes in it. I have ice cubes in it. Now what will happen, that after some time the ice will melt because of the heat exchange with the surrounding. It will lose heat or gain heat. It will gain heat. The surrounding will lose heat and you will see some water droplets also. Here the mass will also change because some water droplets will also accumulate. And what will happen to ice? It will melt. So it is case of open system where mass can be also exchanged. You can pour water from outside also. There can be exchange of energy, there can be exchange of mass. So that is what we call as a open system. Is it clear now? Pressure cooker you can take as an open system because you know pressure cooker is given with a vessel at the top. So when pressure starts building inside and when it becomes in excess, so you will see that there is a vessel at the top of the pressure cooker, and this vessel will rise up when the pressure will exceed its danger value. So when you will see the vessel rises up, you will see steam coming out. So if steam is coming out, what does that mean? If steam is coming out, that means some mass is escaping from inside the vessel to outside. So there is an exchange of mass here, na? So you cannot say that pressure cooker is a isolated system. It is a closed system or an open system. Till the vessel was not lifted, you can treat it as a closed system. But the moment steam starts coming out by lifting off the vessel, we will say that it becomes an open system. I hope this is clear to all of you. See, this is the first class. Physics requires a lot of patience. Being in class, in the beginning, we are dealing with something which later on you will find its use. Some of the students over there, I doubt really that whether they are students or just some people who have unnecessarily come to the class, they are peeping and seeing that what all is going on and they are passing negative comments or whatever. See, if you are a student and doing so, you are doing self-harm, because every year we see such students, after something wrong happens to them, they crib and cry that, "Arey, I wasted my time." So here, if you are sincere, if you listen to the class properly, you will come to know of things properly. Those who are wasting their time, it is an advice that you do something creative in your life which would be helpful for you, and don't irritate others also. Students who are studying, they also by these comments might be they get irritated or they will deviate from their studies. I hope it is clear. Okay. So we talked about system and surrounding. These were some terms. Now next term that we see, you have heard of, is what we call as a force. Now what is a force? What is a force? Can anyone tell me what do we mean by a force? We are gradually moving from one stage to other. First we identified system, collection of objects, single object and all. What is a force? How can we define a force? See, you need not worry about a note right now. You need not hurry and write things. These all videos, presently it is live, it will all be there uploaded in YouTube. So there you can pause, wherever you need to hear again, you can clearly hear it again. Those who are seeking explanation again and again, that in your free time, you have lot of free time, you can play the video and go to that particular moment and you can hear it again, no problem. Pull or push, yeah. If you are saying pull or push, then someone is saying mass into acceleration, okay. I am just asking the basic form because now I am dealing, or I was dealing with system and surrounding. So in this term, if I want to say what is force, so force is any action that tries to change or can change, both things. Either it can try to change or can change either the state of rest or motion or direction of a system. So anything which can influence a system by changing its state of rest, motion, state of rest or motion, or the direction of motion, so that is called as a force. Clear? So this is what we call as force. Now think, if suppose someone tries to apply force on your hand, for example, playfully you are standing over here and your friend comes and what he does is pulls your hand, So if the friend pulls your hand, what will happen? Will your hand get out of your body and will it move away with your friend? Will it happen? Acha, it moves. Suppose you are holding your hand firmly, you are not allowing it to move, and your friend tries to just for handshake and then pulls your hand. Will he take your hand and go away home? No. So what exactly happened when your friend applied that force on your hand? What happened? Why didn't your hand get pulled off? Yes, correct. We got a very good answer which I was expecting. Because of something which is called as inertia. Every object tries to resist any change in its state of rest or motion or direction. So that is called as inertia. Now how can we define inertia? It is nothing but ability of any object or particle or system, you can say. Presently we are talking, we had generalized the object as a system. Ability of any system to resist a change in its state of rest or motion or direction due to an applied force. So whenever you apply a force, the ability or tendency, word would be apt, tendency or ability of any system to resist a change in its state of rest or motion or direction due to an applied force, that is called as inertia. So because of inertia only, whenever suppose I have a liquid in a container, you will see the level will be flat. Now if I move the vessel or container right side, what will happen? Can anyone quickly tell me? If this vessel I move, it was at rest like this. Now if I suddenly move the vessel right side, what will you observe? You can practically also see that. What will you observe? It will shake. What will happen to the shape of the liquid surface? The upper layer of the liquid, what will happen to its shape? Can anyone tell? We'll finish off the class fast. What will happen to its shape? Yes, you will see that the liquid shape will become like this. What is the reason? It can split also, spill also outside, depending on how much size the vessel has. If the vessel is of very large size, might be the water does not spill, but you will see liquid will become like this. Why? What is the reason? It is inertia. Why? You have pulled the vessel, so vessel is going right, but the liquid inside, it was at rest. It will try to oppose the change of its state. The water inside or the liquid inside was at rest, and the vessel which is carrying it, it was also at rest. Now whom did you give the motion? You gave the motion to the vessel. So if the vessel moves, because of inertia, water will try to stay there only. So in doing so, if the vessel moves forward, the liquid will move backwards. That is called inertia. So inertia is the ability or tendency of any system to oppose the state of rest or motion. Very small examples, but important ones we see to day-to-day life. We are moving in a vehicle. Suddenly the driver applies brakes. The driver applies brakes means what he is doing? He is providing deceleration or retardation. He is trying to decrease the speed. But you were in the bus or vehicle. You were moving along with the vehicle. The driver tries to stop it. Stopping means pull the vehicle back. So due to inertia, you will fall down. Yes, correct. Bus journey. The bus, suppose it suddenly speeds up, means it is going fast. Earlier it was going normally. You are inside the bus. You are both. You and bus, you are going normally, but suddenly the bus speeds up, means moves fast, just like here, this vessel and water. So with respect to bus, our tendency was to remain there only. What will happen? We will fall back, and if he applies brakes, we will fall forward. Understood? So this is what we call as inertia. And to end the class, can anyone just tell me what is responsible for this beautiful term called inertia? What is the reason? What is present in any system which causes this inertia? So we will just see the answer of this, and then we will stop our class over here. And from next class onwards, definitely we will see interesting and numerical aspects of physics. But presently we will end with what is the reason for inertia. What is, yes, correct. We have few correct answers. The correct answer, the reason for inertia in a body is what we call as mass. Understood? The more mass you have, the more inertia you will provide against any resistive forces. So with that note, I will be ending today's class. It was a pleasure discussing few things, interacting with you and getting some lovely answers from your end. So God bless you all, and from next class we will be seeing some mathematical aspects. I will try to tell you techniques which will, I feel that they will provide to be very beneficial for you in learning physics. So thank you and bye.